video now that I think about it. Okay, so day 18. Mrs. Jane needs to hire someone to paint a room in her house. Company A's rates can be calculated using the function y equals 15x plus 30, and Company B's rates use the function y equals 25x plus 10, where x is the time in hours and y is the cost. When will the companies cost the same amount of money? Oh, this is bad. My glasses are fogging up. Has anybody got an answer? Kane, what'd you get? 2 and 60? Like this? Okay. Anybody else? Agree? Disagree? Kara, what do you think? I don't know. Joe, what do you think?
Yeah.
Yeah? Is that because you got it or just because it's Kane? Okay. Anybody else? Anyone? All right. Well, we already have that X is number of hours. Okay. And they give us that. And so that's really nice. Y is equal to the cost of the job. Okay. And we know Company A, their rate is y equals 15x. I'm not going to say equals there. That's too many equals. Y equals 15x plus 30. And Company B, there's a song about that. Y is equal to 25x plus 10. And it says, when will the companies cost the same? When will they cost the same? Okay? Now, not for Joe or not for Kane or anybody that got this right away, but what do you think we should do here? We want to know when they cost the same. What do you notice about both of these equations? Oh, it is if you see it. What do you notice? They're in the same form. Yes, that's excellent. What kind of form is it? Slope-intercept form. They both have y isolated, right? Okay, over here we have y equal to this. Over here we have this y equal to this. Well, if y is equal to that and this y is equal to that, couldn't I set these equal to each other? Yeah. So example, Company B says y equals 25x plus 10. That's this one right here. And I'm going to substitute because y is also this amount right here. I'm going to substitute that in and say 15x plus 30 equals 25x plus 10. So whenever you have, guys, look up here. Whenever you have two equations that say y equals something and y equals something, and you need to solve, set those x values equal to each other, okay? And now what we need to do is just solve for x. Get your x's to one side, get your numbers to the other, okay? So I'm going to move my x's to the right. What would I do with that 15x, class?
You would subtract it to 25.
That's right.
And I'm not going to answer anymore.
Okay, I was going to say, class, that was kind of individual, but thank you, I appreciate it. 30 equals 10x plus 10. Get your numbers to the other side. If that is a positive 10, I should subtract. Miss Dee Dee, should I write this down? Well, not if you don't want points for your bell work, but yeah, everybody should be writing this down. So 30 minus 10 is 20. 20 is equal to 10x. I'm solving for x. It's now being multiplied, so I should divide. And x is equal to 2. X, we said, was the number of hours. Okay? I'll put it over here. So there's 2. I need to solve for y. They both already have y isolated, so you could substitute it in for either one. I'm just going to use that first one. Y equals 15x plus 30. Substitute in 2. So y is 15 times 2 plus 30. And 30 plus 30 is 60. So my answer mathematically is 260. 2, 60. But it's a word problem. So we have to talk about what does that mean? Well, x is number of hours and y is the cost of the job. So you tell me, somebody out there in student land, what does this mean? I'm good. I'm glad. I'm glad. What does this mean? Angel, what does that mean? Do you think? You know? No idea? TJ? No. Mari? Anybody? Yes, Makara.
2 hours and cost $60.
Yeah, if they are both charging hourly and for everything, hourly and then plus their regular rate. So after 2 hours, and yes, you should write this down, both will cost or charge $60. Before that time, one of them's going to be more expensive. After that time, it's probably going to switch, and the other company will be more expensive. But at exactly 2 hours, they would both cost the owner, Ms. Jane, $60 if they painted for just $60. Okay? What questions do you have about that? Now, they gave you the equations, they gave you the variables. You have to know, like I said before, if you have y equals something and y equals something, and we want to know when is it going to cost or be the same, set them equal to each other. Okay? All right. Let's go in our packets to page 26. 26, let's talk about elimination. AKA, you're out of here. Sounds really fun to do. You're out of here. Has anybody ever umped or refed for a game for little kids or anything? You really have to be kind of nice with that, I suppose, especially if they're little kids. Oh. Okay. Page 26. Elimination. So we have 3 different methods for solving a system of equations. First way is by graphing. Okay, do they intersect in one spot? Do they have parallel lines? Or are they one line on top of the other? The second method was substitution. And today the third method is elimination. Okay, elimination. All right. This is page 26, I believe, right? 27, my bad, sorry. Page 27. Okay. So, solving system of equations by elimination. You might want to underline or find that, especially if you're wanting to go back to your notes, which I highly encourage. Okay? Systems of equations may be solved algebraically using elimination, which is a process of using addition or subtraction to eliminate one variable. What's it mean to eliminate?
Take it out of the game.
Take it out. Get rid of it. Okay? Key concepts. Multiply one or both of the equations by a number to result in two equations that contain opposite or equal terms. Okay? Then we are going to add. We're not going to worry about subtracting. We're just going to add. So cross out subtract. Add the equations, eliminating one variable, and solve the equation. And then you're going to substitute. So we do use substitution in here once we have one of the variables. Okay? All right, let's take a look at example 4. So what we are looking for is, maybe do this. We are looking for like terms that are opposites. Like terms that are opposites is what we're looking for. Okay? All right, so the first example, example 4. Use elimination to solve the system of equations. 4x plus 7y equals 20. 5x minus 7y equals 8. Where do you see like terms that are opposites? First of all, do you know what an opposite is? So if I say 3, its opposite would be? Would be what? Negative 3. If I said negative 18, its opposite would be? Positive 18, okay? So here in these two equations, where do I have two like terms that are opposites? Why? Because I said so. Okay, yes. Positive 7y and negative 7y. When you see those opposites, I want you to put a box around them. A square, rectangle, whatever you want to call it. Rectangle. Put a rectangle. Put a rectangle on it. Okay. Do that, please. Now, we said we are going to be adding these together. So when I add positive 7y and negative 7y, I'm going to get 0. And those are going to cancel out. So put a big slash now through that rectangle. We have gotten rid of one of our variables. We have eliminated it. So add what we have left in your columns. 4x plus 5y, or 4x plus 5x is 9x. We got rid of the y terms. Equals 20 plus 8 is 28. We're trying to solve for x. What should I do here? Divide by 9. Divide by 9. 9s simplify out, and x is equal to 28 ninths. Can I simplify that at all? Is there any number that divides into both of those except for 1 evenly? No. So that is my answer for x. But I'm not done. And yeah, I know that's kind of a yucky one. Let me make sure. Pretty sure. Ooh, yep. I think that's strange. They started off with one that had a fraction in it, but that's all right. Okay, so then I need to substitute that in. Which equation should I use? Does it matter? No, because I could use either one of them. So I'm going to just, let's see. I'm just going to use the first one. So go back to the first one. I'm going to say 4x minus 7y equals 20. I'm going to substitute this value in 4x. So I'm going to say 4 times 28 ninths minus 7y, whoops, I wanted that in red, equals 20. Yeah. Is it? I don't have my glasses. Okay, thank you. Thank you. Give that man a sticker. Remind me at the end. All right, so I need to try and simplify. We're trying to solve for y. So I need to multiply. This is 4 over 1. 4 does not simplify into 9. So 4 times 28, I think is what, 112? Check my math. I think so. 112 ninths, yeah, plus 7y equals 20. Wow, this is really gross. All right, I need to move this, but trust the process, to the other side. So I am going to subtract 112 ninths. I'm going to subtract 112 ninths. I'm running out of space. These are going to cancel out. I'm going to move it over here and say 7y equals 20 minus 112 ninths. Okay? All right. I need to make this 20 to have the same denominator. Okay? So I want this to be something over 9. How do I go from 1 to 9? Multiply by 9. So I'm going to multiply this top one by 9 too. 20 times 9 is 180 ninths minus 112 ninths. The only reason I'm doing this is I'm trying to simplify this a little. But this is really yucky. The rest of them should not be this hard. So 180 minus 112 is what? 68 ninths. And that is equal to 7y. What would I do at this point? Divide by 7, divide by 7, but we can't divide a fraction. So we need to multiply by its reciprocal, which is 1 over 7. Okay? So can't divide by a fraction. So multiply by reciprocal. So my 7 simplify out. Y is equal to 68 times 1 is 68. And 7 times 9 is 63. So my final answer is the ordered pair. My x value is 28 ninths. And my y value is 68 63rds. Ooh. That is ugly. I promise they're not going to be this bad. Promise. Okay? Any questions on that? I'm just checking. 28 ninths, 68 63rds. That's what I had. Okay, let's do the next two. Multiply both equations before elimination. All right. I don't think we need to do that. That's kind of weird. Okay, so as I look at this, we're talking about elimination. We want to get rid of one of the variables. Say, you're out of here. Where do you see some like terms that are opposites? For example, 5. There aren't any exactly right now, are there?
No.
But there are 2 that have the same coefficient.
Yeah, so technically you can just multiply by -1.
Yes, multiply by -1. So I'm looking at right here. This has a negative 9y. This has a negative 9y. If I multiply this top one by a negative 1, and I mean every term by negative 1, that will change this y term to be a positive, okay? So I'm going to rewrite it below. Negative 1 times negative 2 is a 2x. Negative 1 times negative 9y is a positive 9y. And negative 1 times negative 25 is a positive 25. So now I'm adding these two. Here are my opposites. Put a rectangle around them so you can easily see, yes, those are opposites. They are going to cancel out. And now let's add. Negative 4x plus 2x is how much? Negative 2x. And negative 23 plus 25. 2. Oh, yes, this is going to work out much nicer. So divide by negative 2, divide by negative 2. Negative 2 simplify out. X is equal to negative 1. There's your x coordinate. Now, substitute that into either one of the original equations. It really should be the original. Don't go with the new one that we did down here. So I'm just going to use the top one. So this is equation 1. Says negative 2 times x minus 9y equals negative 25. Substitute this x value in here. Negative 2 times negative 1 minus 9y equals negative 25. Negative 2 times negative 1 is a positive 2. Okay. And I need to solve for y. I need to isolate y. Larry, come on, up here. So I'm going to subtract 2 to get to my numbers all on the same side. I have negative 9y equals negative 25 minus 2 more is negative 27. Divide by negative 9, divide by negative 9. Y is equal to positive 3. So my solution, my ordered pair, is going to be negative 1, comma 3. Yes, that's how most of them should come out. Thank goodness. What questions do you have on that? You want to try to find like terms that are opposites. If they're not opposites, we can force them to be opposites. Okay? All right. Let's look down here. Let me take a look. Okay. Let's do this last one. Example 6. Elimination where there is not exactly one solution. So that means either it's going to be infinite number of solutions or no solution. Okay? All right, so as I look at these two equations, 18x plus 21y is equal to 14. 6x plus 7y equals 2. I'm looking for like terms that are opposites. Do you see any right now? No. But I do see both for the x's and for the y's that if I take 6 and multiply it by a negative 3, that'll make negative 18, and I could cancel those out. Or I could take 7, multiply that by a negative 3, and that's going to be a negative 21, which would also cancel out. Okay? So, whatever the case, I'm going to take this one, the bottom one, multiply everything by this negative 3. Okay? And I am going to actually write it above because I like to have these one on top of the other if I can. So negative 3 times 6x is going to be negative 18x. And negative 3 times 7y is going to be minus 21y equals 2 times negative 3 is negative 6. And I'm going to cross that out because I know I'm now looking at these two. We're adding them. I always like to add. So now I actually see, bless you, 2 places where I have opposites. Negative 18x and 18x. And I also have negative 21y and positive 21y. So when I cancel these out, I have to show something though. When I cancel them out, what do I really have left on the left-hand side?
You have a.
You've got male. No, I don't have male. What do I have? What do I have on the left-hand side when those cancel? What?
You talking about the right side?
No, the left side.
Plus.
What is negative 18x plus 18x? 0. Yeah, even though I cancel them out, I do have 0. They are 0. So 0, bless you, equals negative 6 plus 14 is 8. And you're like, what? That's not true. So what's my solution set here? No solution. No solution, which means that these 2 lines are parallel. Parallel lines. Okay. All right. Well, let's see. Do I want to do one? Bless you again. Let me see here. Dun, 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 dun. Flip the next page. Gosh, we don't have any where we give you where you have to change both, I don't think. Oh, yes, we do. How much time we got? Okay. No, I'm not going to do that. Not going to do that. All right, so let's go to your homework. The homework, which I mistakenly said you should be able to do the whole front page. I did not realize the bottom 2 problems said use elimination. So that was my bad. Okay. So homework number 5. Homework number 5. Yesterday I said do the whole front side. Were you able to do the whole front side? Probably not. Were you? Did you use elimination on the one? Okay, so you kind of knew.
I did too. Because I already knew what we wanted.
Okay. So homework number 5, you should be able to do problems. Are there what, 3 and 4 on there? Is it named 3 and 4? Okay. So everybody turn to homework number 5. I don't think anybody's turned it in yet.
No, I need help on the last 2 problems.
On the back side? Oh, yeah, we're not doing that yet, though. Because that's word problems, and that's going to be on Thursday.
Oh, but I already got one of them done.
That's good. That's good. So, homework number 5, problems 3 and 4. You should be able to solve by using elimination. So, I want everybody to be working on those right now. If you've already done those, spectacular. You get free time. Everybody else, I want to see your homework 5s out, okay? I'll be walking around, seeing if you need any help. The first 2, you're supposed to solve by substitution. And then the bottom 2 should be by elimination. Okay?